So I'm turning your mic off, Kylie, seeing how it causes weird things to come in from your end. So this is new to all of us. I've done a little bit with this online, except for, other than that, those snow days last year, it's been actually teaching a class and not just looking at a blank computer screen. So this will be a little awkward at first, but we'll all get it figured out, and we'll make do the best we can with what we have to work with. You probably know that never in the history, and never in my lifetime, has the whole world been shut down like this. They did some pretty serious quarantining during the 1918 flu. Maybe that resembles what they're doing now. I don't know, but no, very few living people were alive in 1918, so most of us are just making this up as we go. All right. I also don't expect this to take an entire class period because, for the most part, I don't have to keep shushing anybody. All right. Again, if you have specific questions, go ahead and send a message to me. And I also have people asking questions because, again, this is new to all of us. So, yeah, bear with me. All right, so acids and bases. You guys are all familiar with acids. You've heard a lot about acids, but they aren't necessarily what you think they are. People generally tend to think of acids as just caustic things that burn you. And not all acids are burning. Not all acids are extremely caustic. There are some acids we eat. Citric acid is obviously one we eat. Vinegar is, vinegar is acetic acid. So there are a few acids that we eat on a regular basis, but you're familiar with the term acids. You probably are less likely to be familiar with the word base. Just a second. I have to text Mrs. Anthony. All right. Bases you're less familiar with. Bases are the opposite of acids in a chemical sense. And bases can be every bit, even more so, caustic than acids. You may have heard me tell the story about, maybe 100 years ago, back when there weren't the big soap companies, global soap companies, but every town had its own soap maker. There was a soap maker somewhere in the Chicago area who was tired of his wife, so he killed her. And they make soap by putting animal fat in a very strong base, particularly lye, L-Y-E. And so he didn't want to, be hanged for killing his wife. They did that back then. So he dumped his wife's body in one of the soap vats with all of the lye, which is a base, and it totally dissolved her. The only way they proved that he did it was they drained the vat and they took out all the sludge, and they found, I think, her rings and maybe some fillings in the sludge on the bottom of this soap making vat. So bases can be every bit as strong or more so to living tissue than actual acids. All right, so we've got three definitions here. Arrhenius, Bronsted-Lowry, and Lewis. Got to text Mrs. Anthony again. Were you guys able to click on the link, or did you have to copy and paste it? Anyone want to answer that question? All right, so these three definitions are not, okay. I just clicked it. I did it on the app, so I copied it. I just clicked the link. I didn't see a link. I just out the code in. All right, so on the, and I don't suppose I have it open. I don't have it open. On the LMS website, there was a link, and some of you could click it and some of you couldn't. What you really need is that 7-digit code. Just go to the app and type in the 7-digit code, 678. I think it's 8 digits. Type in the 8-digit code, and you should be good to go with that. All right, next question. Are you in second hour or fifth hour chemistry? Okay, back to acids. So we've got these three definitions. These definitions are expanding on each other. As we learn more, somebody else would advance the definition. The first person to define acids was this guy named Arrhenius, Arrhenius. He was a pirate scientist. And he said an acid is any substance which can donate a hydrogen ion. Hydrogen ion, and I think this might be a footnote in the bottom someplace. Oh, right there it is. A hydrogen, same old games it's playing. Just a minute. So hydrogen ion is the same as a proton, because a hydrogen is one proton and one electron. So if we take the electron away, all that's left is a proton. So remember this right here. Remember this, that a hydrogen is the same as a proton. So Arrhenius looked at all the acids, and you remember that we said acids were things that, I bet some of you could answer this, start with hydrogen. So HCl, H2SO4, and you don't have to memorize these. This is just for illustration. H3PO4, three different acids. Three different acids, and they all start with H, because Acids are substances that can donate a hydrogen ion. Now, bases, according to Arrhenius, were any substance which could donate a hydroxide ion, OH minus. You hopefully remember that from the polyatomic ions you're supposed to know. So we've got NaOH and Ca with 2 OHs and Fe with 3 OHs, but they all end with OH. They all have that OH to give. So that was the original definition of acid and base. And at a simple level, most people, unless they're well into chemistry, usually use that Arrhenius definition for acids and bases. Along came these two guys, Bronsted and Lowry. They weren't working together. They both figured this out. And Bronsted said, look, a hydrogen is the same as a proton. So let's rearrange this definition to say any substance which can donate a proton instead of saying hydrogen, which, you know, why make that change? It really changed the definition of acids, but now it changes the definition of base, because a base then is any substance, instead of donating hydroxide, any substance which can accept a proton, because basically, and if you don't understand this, that's fine. What I'm telling you now is just for those who are curious to know. If you put an acid, which according to Arrhenius is H+, with a base, which according to Arrhenius was OH-, if this was actually where you could answer, I would ask you to tell me what you think an H and an OH would make. H and an OH, you may not recognize that, but you would recognize like this. Water. So what is the OH doing? The OH is accepting that H+. Well, if an H is the same as proton, then we could say that the OH was accepting the proton, and then we could say that anything that can accept a proton. So Bronsted and Lowry kind of expanded this idea of a base. And then along came Lewis. Lewis said, electron dots. No! Lewis said, oh, that this is what a electron dot of a hydroxide is. There's the extra electron that gives it the negative charge. So, and here's the hydrogen, H+, which has no electrons. And so Lewis said, that these two electrons are being shared by this hydrogen. So the hydroxide is donating a pair of electrons, and the hydrogen is accepting that pair of electrons. So Lewis just took the same thing and expanded it, can accept a pair of electrons and can donate a pair of electrons. Lewis just took that thing and expanded it, and it made even more things acids and bases. So all this really does is increase the things that fit into the definition. Oh, I do want to point one other thing out, though. These definitions can get a little confusing. Donate, donate, accept, accept. So look at this. See if I can make this make sense to you. Donate, donate, accept, donate. So donate, 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 accept, accept, donate. You'll want to keep track of those as you are as you are learning this. Now, I don't know what we're going to do for tests. I expect to have a test. Depends on when we get back to school. If we get back to school, we'll see. Maybe you'll luck out and all of the tests will be open note, but you will want to make sure that you've noted these, that you can find them in your... Now, there's this big blank spot here. This big blank spot is for the properties of acids and bases. And you get to fill it in, so here we go. Acids, bases. Still straight line challenged. All right, so one of the most obvious physical properties is that acids taste bitter. And bases taste sour. Now, I will tell you that I know the difference between bitter and sour, but I cannot actually define the difference between bitter and sour. So bitter would be like lemons, and sour would be like soap. Because you remember, soap is made from bases and animal fat. Gross, isn't it? So let's see, what goes on here? What do I need to say? I need to tell you that, oh yes, somewhere all of you have accidentally, shall we say, tasted soap. Maybe you were taking a shower and it ran into your mouth. Maybe you said a naughty word and your parents shoved some in your mouth. My parents never did that. My parents just warmed my little hiney for bad words, but you've tasted soap, it's sour. Now, by the way, warning, do not go around tasting acids and bases. When we taste acids, particularly the strong acids or bases, and again, particularly the strong ones, they're very, very, very diluted. We don't take a bottle of Crystal Drano and take a swig to see what it tastes like. They're very diluted before tasting, so don't taste. All right, acids primarily react with metals. And when they do that, they make a salt. Now, the reason I say a salt is because there are actually scores of kinds of salt. Only one kind that we actually eat, but there are scores of kinds of salts. And when I say there's only one we eat, if you eat sea salt, you're eating several, but it's still predominantly sodium chloride. So they make a salt and hydrogen gas, which is H2. All right, bases react with organic material. And when I say organic, I don't mean organic in the sense that we commonly throw it around. I mean it in the actual chemistry definition. Organic refers to anything that was made by a living thing. So Actually, even gasoline is organic because it's the remains of living things. So they react with organics, making soap, which is a kind of salt, believe it or not. Soap is the salt of an organic acid. And instead of making hydrogen gas, they make water. And again, if you have questions, you can type them in. All right, so let's see. Then we have turn, litmus, red. Acids turn litmus red, and bases turn litmus blue. And by the way, they'll go back and forth. If you take a piece of litmus paper and put it in an acid, it'll turn red. Then you put it in a base, it turns back to blue. Then you put it in an acid, and it turns back to red, a base back to blue, and it just keeps doing that over and over and over until the paper dissolves and falls apart. Litmus is a substance that comes from some kind of seaweed. It's an indicator. Someplace down in the notes, we're going to talk about indicators, but indicators are chemicals that turn color at some specific pH, and what the pH is different for different indicators. Now, red and blue is maybe hard to work. I was going to highlight it in red, but highlighting red in red probably doesn't work very well. So, as red ends with D and ends with E. That is how I remember which one is which. Of course, base starts with B, and blue starts with B, so it works for each of them. And there's no way to get mixed up, because acid starts with A, but blue or red don't start with A. Of course, base ends with E, and blue ends with E, so that one might mix you up. I don't know. Try not to get mixed up. All right. Here's my favorite word ever. Acids turn pH NO pH TH, and that pH TH just takes some practice to get. Acids turn phenolphthalein colorless. So if you put phenolphthalein in an acid, you can't even tell that it's there. It looks like there's nothing there. It's actually very cool, because if you then add a base to the acid, the moment that solution turns from acidic to basic, the phenolphthalein that you couldn't even see was there suddenly turns this bright fuchsia pink. Okay, that's phenol. Takes practice. Phenolphthalein. Phthalate, like alane. Oh, Ranger, be quiet. It's just me. Dogs. All right, so let's see. What do bases do? Bases turn what? Phenol. Except I put in quotes because those of you who are all bent out of shape about colors would say, that's not pink, that's fuchsia. And I don't even know, now I said fuchsia, so I probably have to turn in my man card. All right. Sorry about the little random Windows sounds. Some device on my computer is connecting and disconnecting. So let's see. One more thing, or two more things. Acids neutralize bases. Making a salt and battery. No, wait. That's actually a crime. Never mind. Making a salt and water. And the thing works the other way for bases. Bases neutralize acids. Making a salt and water. Thing they make because they're neutralizing each other. So there you go, the property of acids and bases. Now it looks like we've got about 4 minutes till this meeting runs out. So please make sure that you are checking LMS for the quiz. I think it's supposed to be done tomorrow noon or 3 o'clock or something like that. I didn't think to open the website right now, so I have the website open and ready to go, so you'll have to check there yourself. And my intention is to make these lessons available the following afternoon, so this lesson should be available sometime tomorrow afternoon if you want to re-watch it. Or if you were too lazy to get up, and 9 o'clock for pity's sake. Anyway, if you're too lazy to watch it, it's not going to help you with the quiz, I don't suppose. But anyway, all right. Any questions? Got 3 minutes left. Any questions?